Great. So today, and for the rest of the week, we're going to start Chapter 9, okay, which looks at parametric and polar equations. Basically, different ways to graph, okay, other than what we're used to. So when we graph things parametrically, you can get different kinds of equations, with different kind of pictures. Okay? So that's one kind of picture you can get. Off the top of my head, I'm not sure how the exact equation that would make that picture, but we could figure it out. Here's another one. Okay, that one I did look up, and it's very complicated. It's just a ton of stuff to type in to generate that picture. Okay, and the last one, a little bit simpler picture. Just kind of almost looks like a sine wave, but then it kind of comes back and goes the other way. So if you look at all these pictures, every one of them fails a certain test that we use sometimes in math. What test do these fail?
The Turing test.
The what? Yeah, they fail the vertical line test, which means they're not functions, right? Not every parametric equation fails the vertical line test. I'm just showing you some special ones. Everything that you know how to graph now, like parabolas, lines, sine functions, you can graph everything that we already know how to do parametrically. Okay? So you can do everything you still know how to do, plus you can get some new kind of pictures as well. All right, so first I'll just kind of explain what parametric is, and then I'll show you some examples, and we'll do a little graphing on the calculator. All right, so first thing is parametric equations. Kind of the big difference, if I just show you an example, is that instead of just typing in one function, okay, like y equals, and then you type it in, you have two functions. Okay? In order to create a parametric graph, you've got one formula that figures out what's going to happen to the x's, and then a separate formula that tells you what happens to the y's. So it's kind of like you take y equals mx plus b form, and you're splitting it into two pieces. Okay? Each piece is going to separately determine what happens to the x's, and then also what happens to the y's. All right. So since you have two functions, that's what I've started out with here. Okay. Let f and g be two functions. Okay. One of these is going to describe what happens to the x values. A different one describes what happens to the y's. You don't have to call them f and g. Any two letters is fine. And those two functions work on what's called an interval. Okay? And just to show you an example here, that's the interval for this problem, 0 to 1. Okay? Basically, the interval is the domain for t. Okay? It tells you what numbers you are allowed to plug in for t. So in these two formulas, the only numbers that you're allowed to use are 0 through 1. Okay? Any number you want, 0 through 1. And because there's brackets, you can include 0, and you can include 1. Okay? So that interval, it's basically the domain for t. All right, so the idea is that if you take all the numbers 0 through 1, okay, or if you're really doing something practical, you just take as many as you need to make a picture on paper. Okay? And you take all the different coordinates that could be generated. Okay, using the two formulas. You get a picture, and that's called a curve. Okay, parametric pictures, we call them curves. We can't usually call them a function because they're not always functions. Okay, a lot of times they fail the vertical line test. All right, so you take all the numbers that you can generate using your first function, all the numbers you can generate using your second function, which calculates the y's, and you write them as coordinates, graph them, and you have what's called a curve. Okay, and I call it the curve C. That's all. Just gave the curve a name. So the two equations that generate the curve, okay, or that create your picture, those are called parametric equations. Right, so if I go forward a couple slides again, that is a set of parametric equations. 1 minus 2t, and then y equals 2 minus t. Okay, you need both of them in order to make the picture. Okay, and t, that's the letter that we normally use when we do things parametrically. What letter do we use with functions a lot? We don't use t. We use x. All right, so when we write things parametrically, you want to get used to using t. They use a different letter. And t, or x or t, whatever letter you're using, normally we call x the variable. Well, t is a variable, but they give it a different name when it's parametric equations. Okay, they call t a parameter. It means exactly the same thing as a variable. T is the thing you plug a number in for. Okay, what numbers are you allowed to plug in? Well, they'll tell you. They'll give you an interval. Okay, so whether we're graphing things by hand, or if you're graphing things on the calculator, you need to set that interval on the screen, in the window. Okay, and I'll show you how to do that. Okay, when you put your calculator in parametric mode and you go to Window, there's some new options there that we've never seen before. Okay, and it has to do with what's called the interval. Okay, any questions on some of those terms? Interval, curve, parametric equations, anything like that. All right. So when you draw a parametric graph, because you're only drawing it over a certain interval, your graph has a start point and it has an end point. Okay. On the pictures I just showed you, it's kind of hard to see the start point and the end point because I think the graphs connect. Okay. If you have a graph like a circle and it connects and it goes all the way around, you can't really tell where it starts and stops. Okay, so I can't tell that on any of these pictures. But sometimes you might have a parametric graph that looks like this. That's it. So it would have 2 points. I can't tell you which one is the start and the end point in that picture. Okay. I would need to know the equations. I would need more information. But one of these is the start point, and one of those is the end point. Okay, and the way you figure out the coordinates of the start point and end point, which is what we're gonna try to do next. Just take a graph and figure out where it starts and where it stops. Is you're gonna look at your interval. Okay, they're gonna give you a number for A, and they're gonna give you a number for B. Okay, just like in this problem. In this case, it starts at 0 and it ends at 1. Okay, the way you figure out the endpoints of the curve is you use those two numbers. Okay? A has to do with where the curve starts. B has to do with where it stops. And how do you figure out exactly where it starts and stops? Well, take A and plug it into your formula that gives you the x value. And then you're going to take A and plug it into the formula that gives you the y value. Okay, so there's two calculations to find the start point. You have to do a calculation for the x value, and then you have to do a separate calculation for the y value. And then to find where it stops, you're going to do two more calculations. You're going to look at the formula for the x's again, but this time you're going to plug in a different number. You're going to plug in b into the formula for your x's. And then to find the y value, you're going to take b and you're going to plug it into the formula for the y's. Okay, so 4 calculations altogether to figure out where a curve starts and stops. You plug A into the x and y formula, and then plug b into the x and into the y formula. Okay, and then you just calculate the number. Okay, it's usually a pretty straightforward calculation. Okay, we're going to do an example of that right now. All right, so here's our first parametric equation. They give me a formula for x and y, and they give me an interval. Okay, find the endpoints of the curve. Okay, so I want to figure out where it starts and where it stops. This doesn't help me to figure out what it actually looks like. Because if you know where something starts and stops, you still don't know how to get from the start to the stop. Is it just a straight line? Is it like a curve? That part, we'll use the calculator to help us. But at least we know where it starts and stops. Okay, which number up here is going to be the number you plug in to figure out where your curve starts?
0.
0. That's your start. So what we're going to have to do is we'll plug in 0 into the x formula, and then we'll plug 0 into the y formula. And we'll figure out what that comes out to. And then what number is going to control where this curve stops? The 1. So you're going to plug 1 into each formula. Plug 1 into the x formula and the y formula. Okay, do out those 4 calculations, and that'll tell you where the curve starts and stops. Okay, so let's start with plugging 0 in for t in the x formula. So Bria, if I plug 0 in for t in the x formula, what do I get? Yeah, we get 1 minus 2 times 0, which is just 1. So the curve is going to start at 1 comma. And Hannah, if I plug 0 into the y formula, what do I get? Yep, which is 2. So this particular curve is going to start at 1, 2. And Curtis, what if we plug 1 in for t in the x formula?
That would be 1 minus 2 times 1, which would be negative 1.
Yep, negative 1. And if we plug 1 in for the y formula, you get 2 minus 1, which is 1. Okay, so there's the start point and stop point of your curve. All right, so let's look at how we sketch that on the calculator. All right, so to graph things parametrically on the calculator, the first thing you need to do is change the mode to parametric. So if you press mode, you have a few choices. We're going to look at the first 3. We've done function all year. Now we're looking at parametric, and the third option is polar. Okay, so we're going to put it on parametric. Notice when you press parametric now, and then press y equals, the screen looks different. For each equation you want to graph, you have to type in an x and a y. If you only type in 1, you won't get anything. Okay, when we press this button, this xt theta button, what letter normally comes up? X. Okay, when you're in function mode, x comes up. Now when you press it, it's t's going to come up, because you're in parametric. Okay, so I typed in, was it 1 minus 2t?
Yeah, 1 minus.
And then 2 minus t. Okay, so that's the first thing we need to set up. Next thing is I'm going to go to my window. So you still have everything you had before. You've got the x-min, the x-max, all that stuff. But you've also got this t-min and t-max. Well, that's these 2 values. It's the minimum value for your parameter and the maximum value. So we have to type in those 2 values. So 0 to 1. If you don't, you won't get the right picture. Okay, and t-step, I'm just going to leave that the way it is. I'll explain a little more about that in a second. Now my start point and end points, those are all pretty small coordinates. So I don't need to be negative 10 to 10. I'm going to do negative 4 to 4. And I'm going to hit graph, and it's going to happen quickly, but I want you to watch what direction it draws what it's about to draw. Okay, but it's going to happen very quick, so you kind of have to watch it and see if you can see which direction it's drawing. It drew it from right to left because the start point was 1, 2, right? And the end point was negative 1, 1. So when the calculator draws things parametrically, it always goes from the start to the end. Now, if you were to graph that in y equals mx plus b, that always graphs left to right, always. It never does anything different. But parametric, it can graph different directions depending on the start and the end point. All right, let's look at that t-step for a second. Okay. When you graph something parametrically, what the calculator does is it's going to plug in a bunch of numbers between 0 and 1 to try to get an idea of what the graph looks like. In this particular case, these are the numbers that the calculator plugs in. It's going to start by plugging in 0 for t. Then it's going to plug in 0.13. So what the calculator is going to do is it's going to go from 0 to 1 by 0.13. It's actually 0.130, but just I'm rounding it to 0.13. So what would be the next value the calculator would plug in for t? It's going to go 0.26, 0.39, and it's going to keep going. It's going to keep stepping by 0.13 until it gets all the way to 1. So then we would have what would be the next one? 52. You got 65. What would be the next one? 78. And then 91. And what would be the one after 91? Nope, not if we're stepping by 0.13. 1.00? Add 0.13 to that, yeah, 1.04. Now, what was our maximum Tmax? It was 1, so the calculator is not going to graph that one. Okay? The calculator is going to graph these 1, 2, 3, 4, 5, 6, 7, 8 points, basically like this. And then it's going to connect every one of those points using a straight line segment. That's how it graphs. So if I were to do something like, let's just take this picture and save it over here. What if I were to type in 0.6? What values would it graph this time? Where would it start? It's going to start by plugging in 0 for t in each formula, and then it's going to plug in 0.6, and that's it, because it can't go to 1.2. So what's going to happen is you're going to lose a lot of your graph because it can't do anything between 0.6 and 1 because you're not allowing it to step in small enough increments. All right? So in general, if you want to get a good picture, pick a number for your t-step that divides into t-max. Like if I did 0.1, now it would graph 0, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1. Okay? If you pick something that's too small, okay, so now the calculator is going to go from 0 to 1, counting by 100ths. So how many points are there between 0 and 1 if you go by hundredths? 100, right? 0.01, 02, well, 101. I always get confused with that. But yeah, it's basically going to graph 100 different points, so it's going to draw it a lot slower. And if you go too small, then it's going to take forever. What kind of shapes do you think it's important to graph enough points so you get an accurate picture? Anything that curves. Yeah, if you've got things that curve, and let's say you tried to draw a circle with only 4 points. The calculator would put those 4 points, and it's going to connect everything with line segments. Okay, to draw circles, you really, you need more points to make it look smoother. Okay, but that's what the t-step does. Okay, I kind of call it like the resolution of your picture. How many points is the calculator graphing to show you what you want to see? Okay, I usually, if you're graphing somewhere between 30 and 40 points, the calculator is going to do it pretty quickly. Even 100 points. the calculator can still do it pretty quickly. You don't need to graph thousands of points. You don't need to set the t-step that small. Okay? What will happen is the calculator will just, it almost look like it freezes, and then you have to shut it off to stop it and turn it back on. Okay, so those are the new things under the window: t-min, t-max, t-step. Okay. Any questions on that? All right, so next thing we're going to look at is what's called eliminating the parameter. Basically, it's just a fancy way of saying take a parametric equation and turn it into what we're used to doing. Turn it into a function. So when you eliminate the parameter, you're getting rid of t. Right? And you're turning it into like y equals, and then a formula like you're used to. Okay, so we're going to do that with example 1. The reason this one's a good one to do is because we already know the shape of it. It's a line. Right? I showed you the picture. That's the picture. It's actually not a line. It's a line segment. So what's the equation of a line that you learned like back in algebra 1, pre-algebra? Yeah.
Well, I have two things. Y equals mx plus b.
Yep.
But, so the question is asking to turn into a function, right?
Yep.
Isn't it already a function?
So this one is a parametric function, but they're going to want us to convert it into a non-parametric function. We're going to eliminate the parameter. So the directions you would see on a problem would say something like that. Eliminate the parameter. All right, so if we want to eliminate the parameter, you have to get rid of this. You want it to be y equals, but you don't want t, you want x. How can I find something I can replace t with? Where could I look? You don't have to tell me how to do it, but there's something up here that could give you a formula for t. Where is that? John?
X equals 1 minus 2.
Yeah, the x equals 1 minus 2t. What would you have to do with this equation to get a formula for t?
Or we'll get t alone.
Yeah, get t alone. If you can get t alone in this equation and then plug it in, that's how you eliminate the parameter. Okay, so if you want to write steps down, step 1, solve the x equals equation for t. Okay, so let's do that. So x minus 1 equals negative 2t. And my last step? Divide by negative 2. And I'm going to do it like this. You can do it all as one big fraction, but I'm going to do it separately, just so I can simplify everything separately. So that's gone. What's x divided by negative 2? Really, it's like an x with what number in front of it? Not 1, but
It'd be negative 2, right?
it would be negative, but
Negative 1 and 1
Negative half.
negative half. Okay, so that's how I'm going to write it. Because when we write things in y equals mx plus b, that's how you do it. You put the number in front of the x. And then negative 1 divided by negative 2 becomes positive a half. Okay, so there's a formula for t. We're going to take that, fill it in right there, and then we'll have some like terms, and then we'll have our answer. So y equals 2. Now, why did I put parentheses? It would be wrong if I didn't.
Oh, it'd say plus half x. Well, it would say minus half, but that could change that.
So we are going to have to change it, but what do the parentheses force me to do now? I have to distribute. That's important. That negative applies to t, whatever t is. So if t is many things, then the negative applies to everything. So that's why you have to put parentheses. Okay, so you get y equals 2 Let's do 2 minus a half first. What's 2 minus a half? So 1.5. And then I still have the minus a half x.
That's positive.
Positive,
Half of X.
positive half x. So there is the equation of what we just drew parametrically.
What was the two?
What's that?
Oh, never mind.
The 2? Oh, the 2's not distributed,
Yeah, I
right?
know, I didn't see the like term, so.
Yeah, so we combine the 2 with the negative 1/2, and that's 1.5. So if you go back and look at the picture we just drew, it should cross the y-axis at exactly 1.5, which it does, and it has a slope of 1/2. Right? So if you were to type in, where is it? The equation we just came up with into your calculator, would you get exactly that picture? No. What would happen if you typed it in?
It would continue up and down.
Yeah, it would continue, it would look like that. It would graph the whole thing. So the important thing we have to make sure whenever we eliminate the parameter is this. We have to remember that the original curve might have not gone on forever. It might have been limited. It might have had a start point and an end point. So what do you also have to write? You have to put down the domain for x. How do you know the domain? That's what we just did with the start point and the end point. So when you write the domain, you don't need the y value. All you need is the x value. And in general, it would look something like this. Take, let's see. You take t min and plug that into the x function. That's how we found the starting x value. Okay. And then take t max and plug that into the x function. That'll tell you the minimum and maximum values for x. So you might end up with something like -1 is less than or equal to x less than or equal to 3. That's telling you your x's are between -1 and 3. Okay. If you want to see exactly what it would be for our problem, I just have to go back and look at what we did in example 1. Okay, my lowest x value was -1. My highest x value is +1. So you only want to draw the sketch between -1 and +1. That's where the picture is. Okay? And we get it just from those two numbers right there. Okay, so the full answer, if you were converting this to a function, would be to write this. And what I have in the black box next to it. Okay, that's the formula. That's where to draw the formula. Okay, so the domain must be restricted. You have to write down the restriction. The domain, you plug t min into the x function, and actually, I'll just write it out. Plug t min into x function. And then plug separately t max into x function. And then whichever one is smaller, put that on the left. Whichever one is bigger, put that on the right. Put the x in the middle. Okay? So then, smaller value, it's usually a less than or equal. Put your x, bigger value. Okay, I can't technically tell you which one is going to be smaller and larger. I don't know. Depends on the formula. But find the two values, plugging in t min and t max, and then put the smaller one on the left, bigger one on the right, and the x in the middle. Okay, so we'll try it. Let's try it on this one. Right, so they want us to eliminate the parameter. Okay, first step, take the x equation and solve it for what? T. So if you solve this for t, what's t? X plus 1. And where am I going to plug in that x plus 1? Plug it in for what?
Plug in for t squared.
Careful, I'm being a little picky. Plug it in for t. Yes. So plug that in for t. So you get y equals, again, make sure you put the parentheses, that's important, and that's your answer. The only thing I have to do is write the restriction. What is x between? Because if I just drew this, it's a parabola, shifted 1 unit to the left.
0.
But the original problem had a restriction. So that's the restriction on t. The t values are between 0 and 3. But we have to figure out what the x values are between. So, well, what am I going to do with the 0? Where do I plug that in?
Oh,
To the x equation. And then I'm going to plug the 3 into the x equation. And I'm going to get those two numbers. Okay, let's start with 0. What's 0 minus 1? Okay, so my graph is going to be between -1 and, plug 3 in, 3 minus 1, 2. So it's a parabola, but you're only sketching it between -1 and 2. And I know to put in the less than or equals because I had brackets. If I had a parenthesis, then I wouldn't put the equal to. Okay, so that's the answer. That's the equation. That's where you sketch it. Now, if you wanted to know the exact start point and end point, you would also need to plug in into the y formula. But I'm not asking for the start point and end points here. Just the starting x and the ending x. That's the domain. So the equations I gave you work out pretty nice, but in general, it's not always possible to eliminate the parameter. If I give you a problem on a test, I will make sure that it's one you can do. Okay. But you can always do the reverse. You can always take something and turn it into parametric. Always. And the simplest way to turn something into parametric is just to use this trick. Okay, the trick to turn something into parametric really, really simply is to say, all I'm going to do is let my x equation equal t, and then in the original formula, replace everything with a t. Okay, it's kind of a cheap way to write it, but it does work. Just say, let x equal t, and then in your y formula, change all your x's to t's. And technically, that is parametric. Okay, so we'll try that here. Okay, I want to turn that equation into parametric. So what did I say to let x equal? Just let x equal t. And then what would your y equation become?
Rewrite it,
Mhm.
set just as t.
Yeah.
So 3t to the fourth plus 7t cubed minus 8t squared plus 2.
Yeah. And technically that's parametric, okay? Because you've written it with two equations. Your x equation is so simple, why you wouldn't really bother doing this. Why not just leave it as a function if you're going to do that? Okay? And the way you could check your answer is take your x equation, solve it for t, which it already is, and then plug what t equals back into the original. So any questions on how to write something that's not parametric as parametric just by doing that little trick? It's a little harder if I said, don't let x equal t. Like if I said, let x equal t plus 1. Now come up with y. Come up with y. It's a little harder, not too much harder, but you have to think about it a little more than just changing x's to t's. Okay. All right, so if we want to write a circle parametrically, it's one of the curves we can look at. Basically, the idea is if this is a point, what's that distance that I just drew? It's the radius. And when you think of things parametrically, you have to separate the x and the y, two separate equations. Well, if you take that point and draw a triangle, I've just separated the x part from the y part. I would just have to come up with a formula to figure out each of those. So normally we call our angle theta when we're dealing with an angle. But when you're using parametric, what letter do we use? T. So T is an angle. What trig function has to do with adjacent and hypotenuse? The tangent opposite over adjacent. Cosine. Adjacent over hypotenuse is cosine. So x has to do with cosine. And we've already done this with vectors, so I'm not going to go through how you break things into components again, because we already did it. And what about y? What trig function does y use?
That's tangent. The opposite.
Opposite, and we want hypotenuse.
Letter sine.
Sine, yeah. So using those two trig functions, you can break this into its components if you wanted to think of it almost like a vector. So if you wanted to write a formula for x, it would be r cosine theta, or r cosine t. And y would be r sine t. That's the formula for the equations of a circle. Okay, just using right triangle trig. So, if I asked you to write the equation of a circle with a radius of 2, what would be the x equation? Oh, Fred, what would be the x equation?
X would be 2
Yep.
cosine t.
T. And how about the y equation?
2 sine.
2 sine t. Now, when we sketch that, let's do it in degrees. I have to type in each equation, 2 cosine t and 2 sine t. Now, what does t have to be in order to get a full circle? What values would you have to plug in?
360.
Yeah, you have to go all the way from 0 to 360. Watch what happens if you don't. Let's go 0 to 180. Okay, if I only go 0 to 180, I'm only going to get half the circle. If I want the full circle, I need to go 0 to 360. And I'm going to step by 5s, so it'll graph it a little faster. Yeah, it looks like an ellipse because remember, this is a rectangular screen. So if you set the same dimensions, -4 to 4 and -4 to 4, it's going to distort it. If you want to see it the way it should look, if you press zoom 5, it'll make it look less distorted. Yeah. Now, what if in my window I did steps of 90 degrees? What would this look like if I hit graph? What's that?
Like a square.
Oh, I'm sorry. Let's, instead of changing that, you're right. It would only draw a quarter of a circle. What if I did that?
It wouldn't graph all points in between, so it'd be straight lines.
It's going to draw straight line segments from 0 to 90 to 180 to 270 to 360. So the smaller you step the t-step, the more points it's going to graph, and eventually it starts to look more and more circular. So if you're going 0 to 360, I think even if you went by tens,
No,
yeah, keep that at 360. But if you step by tens, I think it'll still look pretty circular. You can kind of see some of the edges look a little straight, but it's not bad. Okay, so in our example for that circle, both the domain and range were -2 to 2. Okay, just look at the picture. It's -2 to 2 on each axis. But in order to get a full circle, the parameter had to go from what to what? 0 to 360. And generally, we don't include both 0 and 360 because they're the same thing. So that's just a 0. If you were working in radians, it would be 0 to 2 pi. So the last thing, which I'm going to hold off on, was basically just graphing some different pictures and seeing what they look like. Okay? So if you want to try those, they're probably going to have you do some in the homework. I'll put them in the video so you can see them. But it's just playing with the calculator, typing in different things and seeing the shapes you get. Some of the graphs you get look like this. They have kind of this like shape that like does that. I think one of these is a spiral. So if you want to see that, you can try example 5. And example 7 looks something like this. Just different shapes to look at. And this last shape that I just showed you is called a cycloid. Okay, that's the only one I'm going to give you a special name for, and that's the last thing. Okay. So if you have an equation of this form, A can be any number, like 3, 4. Okay? Anything that looks like that is what a cycloid would look like. Okay? It's that pattern that kind of goes like this. And you could try changing A and see. Does it make it taller? Does it make it shorter? Does it make it repeat faster? You can play with the numbers and see what changes. But that's kind of the best way to get used to parametric. Just try typing different things in and play with it. Okay, but that, again, that shape is called a cycloid. And that's the last example on the other page. Okay, so the homework, it's a little bit of playing around with the calculator, just trying some different things. Okay, and we went through some of those kind of quick. So if we need to spend more time tomorrow playing with the graphing part, just let me know, because we'll have plenty of time to do that tomorrow. Okay, but the homework is on 481, and it's 1 through 5, just the odds, 7, 9, 11, 15, 17, 21, 22, 25, and 29 to 32.